Hi everyone, welcome to the second part of our 8.2 lesson, modeling equations or modeling systems. We just finished a question where we were comparing two ski rental stores. Let me move this out of the way. Okay, and they had different rates and different initial fees, and they both had constant rate of changes. So we had two linear equations that we could write equations for, and that's what we did. So for the first store, we came up with y, which is cost, equals 8x plus 30, and x represents time in hours. And for the second store, we have y is equal to 14x. So cost equals 14 times the number of hours. So once I've done that, I've got my two equations to represent the two problems that I have. I can then solve. So to solve the system, sorry, I'll just move this out of the way for you. Okay, to solve the system of equations, again, let's remember what we have. So let's just, number one, store one. Okay, we have y is equal to 8x plus 30. Okay, and store number two, we came up with the equation y equals 14 times x. And in both cases here, okay, x is time in hours, and y is the cost in dollars. Okay, so to solve this, I have a couple of choices. To solve, remember, to solve this, I'm looking for a point that they both share. So if I graphed it, it would be the point of intersection. So to solve, I could graph both lines and find the point of intersection. That's the solution. Okay, that's one option. Or I could use tables of values. To find the solution. Remember that the solution is a point xy that is the same for both of these equations. So what I'm really asking myself in reality here, the solution for this will be the point that both equations share. So in other words, I'm looking for the same cost for the same time. So at what point will the cost be the exact same for the same amount of time? Okay, so in other words, what would be the only time that I could ski for where both stores, 1 and 2, would cost me the same amount? So there would be no advantage to going with the store 1 over store 2. Okay, what would be the one point that they both share? So we could do that. We could go ahead and solve it using a table of values. So let's go ahead and do that. Okay, again, you could graph it. Either one is a great way to solve. I'm going to use the table of values. So let me just okay, I'm going to solve by table of values. So what I'm going to do here is I'm just going to set up a table of values for each one. So here's store 1. Okay, I have the following. Y is equal to 8 times the number of hours, x, okay, plus $30 for my initial fee. And over here for store 2, I have y is equal to 14 times x, where x is the number of hours. So we're going to go ahead and pick some values for x and y. So x always comes first and then y in my table of values. And remember that we always pick just some values for x. We go ahead and pick some of the independent variable. So we could say, let's start off at time equals 0. There's no point in choosing negative values here for time. So let's say at 0 hours, okay, well, what's the cost going to be? Well, if I look at store 1, if x equals 0, at 0 hours, the cost is just $30. Okay, well, over here at store 2, the cost, if I put a 0 in for the x, y is equal to 0. So there's no cost if I don't ski at all. Okay, whereas with store 1, there is an initial cost of $30. The next one that I'm going to do is put in 1 hour. So let's find out what happens after 1 hour. Okay, so let's put in a 1 for x into store 1 into my equation. So I get 8 times 1 is 8. 8 plus 30 is 38. Okay, and for store 2, if I put in a 1 for x, I get $14 for y. Okay, and maybe we should go ahead and put in for ourselves that, remember that y is money. Okay, and x is hours. Just to kind of put some context behind what we're solving. Let's go ahead and say what happens after 2 hours, because I don't have a common point yet. So after 2 hours, if I put in a 2 for x, I get 2 times 8, which is 16. 16 plus 30 is 46, so it'll cost me $46 if I ski for 2 hours. Store 2, if I put in a 2, I get 2 times 14, which is $28. Okay, and let's keep going. So we've got 3 hours. Let's put in a 3. If I put in a 3 for x here, I get 3 times 8, which is 24. 24 plus 30 is $54. If I put in a 3 into my second equation, I get 3 times 14, which is 42. I'm getting pretty close. 40, 54, and 42. I'm getting there. Again, let's just keep going. So I put in for 4 hours. Let's see. Well, if I put in a 4 for x into my first equation, I get 4 times 8, which is 32. 32 plus 30 is 62. And on the other side, 4 times 14 is 56. These numbers are getting close. Let's try 5 hours. Okay, 5 times 8 is 40, and 40 plus 30 is $70. If I ski for 5 hours with option 2, I have 5 times 14, which is $70. Aha! I have finally found my solution. If I ski for 5 hours, both stores will cost me the same amount. So that is my solution. So the solution is $5.70. In other words, if I ski 5 hours, the cost is $70, okay, for both stores, no matter which one I ski at. So I can see that if I ski less than 5 hours, the cheaper option is actually store 2. But if I ski more than that, I could go ahead and keep going. I'll see that actually store 1 turns out to be the cheaper option if I'm going to ski more than 5 hours. But the only point they both share is $5.70. Okay, so this is solving a system using a table of values. We could have also graphed it, would have been a great way to solve it as well. And we would have found that the 2 lines crossed at the point 5.70 on my graph. Just so you know, if you did graph this, okay, you would have graphed y, which will be cost in dollars, okay, against time in hours, x. And you could have graphed it using a table of values and then graphing both lines. Or we could have used the y-intercept and then use the slope to find the next points on the lines. Okay, so there's more than one way here again that we could have graphed it, but if we did graph them, we would be looking for the point where they crossed, and they would cross at 5.70. So if we were going ahead and graphing this, it might be a good idea to let our x-axis, each division equal 1 hour on some graph paper. But the cost, because we're dealing with bigger numbers, you could go all the way up. Every division equals 1, or we could make every division equal to $10. Would be a good idea, just so that we don't have to have such a big sheet of graph paper. Okay, and then we could go ahead and graph those. That's it for modeling equations. I'm going to get you to try some now in your textbook. So in your textbook, you're doing page 440, number 1 and number 3. Best of luck. If you want a challenge question, number 5 is a great question to try, but I'm only assigning questions number 1 and 3 for you to do as practice. So question 5 is just optional if you'd like to do some more challenging examples. Thanks for joining me today and good luck. Bye for now.